Hello and a very good evening to one and all present here, and welcome to the session on your number system. So in today's session we are going to deal with two things. One is going to be cyclicity and then the other is going to figure out the last two digits of a number. Okay, so we'll be starting off the topic with the easier one, which is going to be cyclicity. And what does cyclicity mean? Cyclicity is nothing but figuring out the unit digit of any expression using our cyclicity. Okay, so how do you figure out the unit digit of any expression? Let me take some examples of few expressions here. Now have a look at these. 407 minus 42. What would be the unit digit of this number? Simply without subtracting the numbers, I can simply say that 7 minus 2, 5 is going to be the unit digit of this expression. And for the second one, I can say that 7 plus 2, 9 is going to be the unit digit of this expression. And here 7 into 2, 14. So 4 is going to be the unit digit of the expression. So the unit digit of any expression depends upon the unit digit of all the terms that are involved there and the operator that is involved. Okay, so this is going to be very simple. Now what kind of questions do come in the paper? Now look at this number, 23 to the power 43. So when I have a question like this, okay, how do I solve it? Can I express in terms of plus operator or minus operator or into operator? I can. The multiplicative operator I can make use of. I can write 23 to the power 43 as 23 into 23 into 23. This keeps on going 43 times, right? So this number can also be written as 3 into 3 into 3, 43 times. So the unit digit number of 23 to the power 43 would be the same as 3 to the power 43 here. Now, even 3 to the power 43 is going to be a very huge number. So what do I need to do? I have to look out for a pattern, or I have to look out for a cycle or something like that. I have to figure out so that I can figure out what is going to be 3 to the power 43. Because in the examination, I cannot figure out what is 3 to the power 43 and look at the unit digit of that number. So let's have a look at the pattern. Now see, 3 power 1, the unit digit is 3. 3 square is going to be 9, unit digit is 9. 3 cube 27, so unit digit is 7. 3 power 4, 81, so the unit digit is 1. And after this, 3 power 5 is again going to be 3. 3 power 6, 9. So the unit digits after every 4 terms, the unit digits are going to repeat themselves. So I can say that the cyclicity of 3 is going to be 4. That means after every 4 distinct terms, it is going to repeat itself. Okay. Now, and I also observe that 3 to the power any multiple of 4, the unit digit is going to give you 1. Right? So first it's going to come like 3 power 1, 3 power 2, 3 power 3, 3 power 4, then again 3 power 5, 3 power 6, 3 power 7, 3 power 8, 3 power 9, 3 power 10, 3 power 11, 3 power 12. So this is how it's going to repeat itself. So for 3 to the power 43, I know that for any 3 to the power a multiple of 4, the unit digit will be the same as 1. Okay, so I can write this number as 3 to the power 40 plus 3. If it was at 3 to the power 40, then the unit digit would have been 1 here. But it is 3 extra. So that will become nothing but 3 power 41 here, 42 here and 43 here. So the unit digit of this number would be the same as 3 to the power 3, which is going to be nothing but 7. Okay. So yeah, let us also have a look at one more small example. Now say for example 3 to the power I have 52. Okay. Now this number 3 to the power 52. Again, I know the cyclicity of 3 is going to be 4. So after every 4 terms, they are going to repeat itself. And I also know that at any value 3 to the power a multiple of 4, okay, the unit digit is going to come out as 1. Correct. So now tell me, 52, is it a multiple of 4 or not? 52, is it a multiple of 4 or not? Yes, exactly, right? So this number is in the format 3 to the power a multiple of 4. So exactly the unit digit is going to be nothing but 1. I can say that. So let's take one more example. 3 to the power say 62 is there. Okay. So 3 to the power 62. Now my base is 4, the multiple of 4, right? I can write this number as 3 to the power a multiple of 4 plus 2, 60 plus 2. So 3 to the power 60, which is a multiple of 4, would have come here. So 3 power 61 would have been here, 62 would have been here. So the answer would have been the same as 3 to the power 2, which is going to be 9. Understood? So in simple, what I'm doing, I'm taking the power, okay, I'm dividing it by the cyclicity and I'm figuring out the remainder. So if here in this case the remainder is 3. So now this becomes a new power. So 3 power 3 I do and I get the answer as 27. So 7 is the units place. Here 3 to the power 52. Now I take the power 52 divided by 4 and I get a remainder of 0. Now it means that this is a multiple of 4. When I get a remainder of 0, it means that it is a multiple of 4. So directly I know 3 raised to the power multiple of 4, the unit digit is always going to be 1. Okay, and remember that here I am not doing 3 to the power 0. I am not doing that. Remember it. Okay, I am doing it as 3 to the power a multiple of 4 because I know that when the remainder is going to be 0, the number is a multiple of 4. So in this case, now I take the power again 62 and then I divide it by the cyclicity and I get the remainder. So now this becomes a new power. So 3 square 9 becomes a unit digit. So this is how we do questions based on cyclicity. Okay, and this is very easy. So 11-1 problems can all be done using this particular way. Okay, the only thing that you need to know is you need to know the cyclicity of all the digits, the digits 0 to 9. Okay, so if you keep that in mind, any kind of a question can be done in this particular way. So now let us just move ahead. Okay, and what I'm going to do is I'm just going to gist down all the cyclicity. Okay, see, if you have 0, the cyclicity is going to be 1 because any number ending with a 0 raised to the power anything will always end with a 0. The same thing, any number ending with a 1 raised to the power anything will always end with a 1. So cyclicity is going to be 1 here as well. Okay, and here for 2 the cyclicity is going to be 4 and the pattern will be like 2 power 1 is going to be 2, 2 power 2 4, 2 power 3 8 and 2 power 4 16. So 6 is the unit place. So 2 4 8 6 will be the cyclicity. And for 3 we just saw the cyclicity was 4, 3 9 4 3 9 7 and 1. Okay, and then for 4 I can say that the cyclicity is going to be 2. 4 power 1 is going to be 4, 4 square is 16, 4 cube is 64. So 4 6 4 6. So or in other words I can say 4 to the power odd will always end with a 1, with a 4, and 4 to the power even will always end with a 6. Right, and any number ending with a 5, the unit digit of that number will always be 5. Any number ending with 6, the unit digit will always be 6. So again here in these two cases the cyclicity is 1. For 7 the cyclicity is going to be 4. Okay, 7 power 1, 7 power 2 will be ending with 9, 7 cube will end with 3 and 7 power 4 will end with 1. Right, and for 8 also similarly the cyclicity is going to be 4 and the cyclicity will be like 8 4 2 6, again 8 4 2 6 and so on. And the cyclicity for 9 will be 2. 9 power odd will always give you a 9 and 9 power even will always give you a 1. Okay, so once these cyclicities are known, okay, now see, I'm going to take any kind of a question now. Say for example, let me take 27 to the power 493. So for this particular thing, what do? I look at the cyclicity of the unit digit which is 7. So 7 cyclicity is going to be 4. Now I take the power 493, I divide it by the cyclicity 4 and now I try to get the remainder. What is the remainder here? 92 is a multiple of 4, the remainder is going to be 1. So the answer will be the same as 7 power 1 which is going to be nothing but 7 itself. Okay, now if I have a number 47 whole power 400. So now I can say 400 divided by 4. The remainder is going to be 0. So which means the power is going to be a multiple of 4. So 7 to the power, cyclicity is 4, only 7 to the power 4. What's going to be the unit digit of this number? 7 power 4, I can catch it from here. It's going to be 1. That's all. Right? So cyclicity of numbers. Okay, these are level 1 kind of a problems which can be done very easily if you remember the cyclicity of each and every digit. Okay. Now, apart from this, there are also questions which are actually slightly on the difficult side. Say for example, I have a number which is in the format 7 to the power 4 to the power 9 to the power 3 to the power 7. Okay, now I need to figure out what's going to be the unit digit of this number. Okay, what's going to be the unit digit of this number? So to figure out the unit digit of the number, what do I generally do? I take the power 4 to the power 9 to the power 3 to the power 7. Okay, and now I divide it by the cyclicity. What is the cyclicity of 7? The cyclicity of 7 is going to be 4. Now I know that this 4 to the power something is a multiple of 4. A multiple of 4 divided by 4, the remainder is going to be exactly 0. So I know that it's a multiple, the power is a multiple of 4. So I directly take 7 and raise to the power 4. I get a unit digit of 1. That's it. As simple as that. Now, let's take next 7 to the power, 5 to the power, 9 to the power, 3 to the power 7. Now here, I can also say that the power here is 5 to the power, 9 to the power, 3 to the power 7. I take this power divided by the cyclicity. 5 by 4, the remainder is 1. So I get it as 1 to the power, 9 to the power, 3 to the power 7. Okay, this I get it as 1 to the power 9, see, 5 by 4, the remainder is 1. So 1 to the power 9 to the power 3 to the power 7 is nothing but 1 itself. So the remainder is 1. So the answer would be the same as 7 to the power 1, and 7 would be the unit digit. Now let's take this 7 to the power 6 to the power 9 to the power 3 to the power 7. So take this power 6 to the power 9 to the power 3 to the power 7 divided by 4. Okay. Now here I know that 6 by 4, the remainder is going to be 2. So 2 power 9 power 3 power 7 divided by 4. Remember 2 to the power anything. 2 to the power anything where n is going to be greater than 1. This will always give you a multiple of 4. This will always give you a multiple of 4. Which means 2 to the power 9 to the power 3 power 7 also is going to give you a multiple of 4. Like see now 2 power 2, okay, is going to be 4. 2 cube is going to be 8. So all 2 power 4 is going to be 16. All these will be multiples of 4. So, or I can also say any even number raised to the power n where n is greater than 1. Then I can say that this will always give you a multiple of 4. So directly here itself 6 to the power 9 to the power 3 to the power 7. Okay, that itself in the format even number to the powers n, the n is greater than 1. So I would have got it as a multiple of 4, and a multiple of 4 divided by 4, the remainder is always going to be 0. So now what do? I know that it's a multiple of 4, so I take 7 and raise it to the power 4. So I get a unit digit of 1 again, right? Now, if I want to do another question, like say for example 7 to the power, 7 to the power, 9 to the power, 3 to the power 7. So for this particular question, the power is 7 to the power, 9 to the power, 3 to the power 7. Divide by 4. Now 7 by 4, I can say, now when I am dividing a number, there are two kinds of remainders that are possible, right? A positive remainder and a negative remainder. Positive remainder tells me how much excess there is, and the negative remainder tells me how much deficit there is. Okay, so 7 divided by 4, there's a deficit of 1. 8 by 4, the remainder would have been 0. So from a multiple of 8, there's a deficit of 1. So I can say this is minus 1 to the power 9 to the power 3 to the power 7. So this number, this whole number, if you take 9 power 3 power 7, okay, there are only two cases. Minus 1 to the power odd would be minus 1, okay, and minus 1 to the power even would be positive 1. So I just have to check whether the power is odd or even now. Now 9 power anything, 9 is an odd number. Odd number to the power anything would always be an odd number. So minus 1 to the power 9 to the power 3 to the power 7 would be the same as minus 1 to the power odd. So I would get minus 1 here. Okay, but remember when I'm dividing a number by 4 and the remainder is minus 1, the positive remainder is 4 minus 1, which is going to be 3. So now the new power becomes 3. So 7 cube, the unit digit of this number is going to be 3. So 3 would be the unit digit of this number. Okay, so I took here 4 different examples. Why? Because I know that the cyclicity of any number can be a maximum of 4. So I took it a multiple of 4 plus 1 plus 2 plus 3 and then I did it. So this is going to be the case for any kind of a number that you get. Okay, so for your practice based on this cyclicity, let us take a few questions here. Okay, please do try this question and I'm going to give you a maximum of 1.5 minutes for this. Please do it. We'll start the discussion soon. And please put your answers on the chat box. This is going to be a short session because once you get the concept, application is very easy and the questions turn out to be very short. So please do it fast. Give me the answer. Okay, so for this question, I'm going to start the discussion. Why? I'll tell you because it's a very easy question. See, the unit digit of this number is going to be nothing but 4. And what is the cyclicity of 4? The cyclicity of 4 is nothing but 2. We saw that 4 to the power odd, the unit digit was 4. And 4 to the power even, the unit digit was 6. This was the only case. Now you just have to figure out whether this power is going to be odd or even. Now see, 23 is an odd number. So odd number raised to the power anything. Will it be odd or even? It will always be a odd number. Even raised to the power anything will always be even. Odd raised to the power anything will always be a odd number, right? So this is nothing but 4 raised to the power a odd number. So 4 raised to the power a odd number, the unit digit is going to be 4 itself. So as easy as that. Okay. That's why I give you very less time for that. Now please take this question. Okay. And I'll give you another 1 minute for it. Please go ahead. Please put your answers on the chat box. Right, enough of time for this. Now you look at this, the unit digit of this number is nothing but 7, and of this expression is 7. So what is the cyclicity of 7? It's going to be 4. So let me write it down also so that you remember it. 7 power 1 is going to be 7. 7 square 49, so 9 here. 7 cube 343, so 3. And 7 power 4 is 2401, so 1 here. Right? Now find the unit digit of this number. So I take the power, first of all, 77 to the power 49 to the power 31, and I divide the number by its cyclicity 4. Now 77 divided by 4. I know that 76 is a multiple of 4, right? 76 is a multiple of 4. Yes or no? 72 is a multiple of 4. 76 is a multiple of 4. Yes or no? Yes. So I can say 76 is a multiple of 4. So remainder is going to be 1. 77 divided by 4, the remainder is going to be 1. Okay. So 1 raised to the power thing will give you a remainder of 1 only. So the answer for this is going to be the same as 7 to the power 1, which is going to give you 7 in the unit space. Very, very simple question. So the questions will look complex, my dear, but maximum the cyclicity can be 4. So the remainder either has to be 1, 2, 3 or 0, which means it's a multiple of 4. So these are the only 4 cases that will arrive ultimately. Okay. So if you know how to figure out the remainder of a number, then it's going to be very, very easy for you. Right. So with this, we will just leave off now the cyclicity, and we will now go to figuring out the last 2 digits of a number. Okay, right. Let's go with it. Now, figuring out the last 2 digits of a number. Okay, so for this, you definitely have to remember a few tips that I'm giving you right now. Okay, so I am going to divide the numbers into a particular formats, and we will be looking at what would be the last 2 digits for all those cases. So when you are doing any question, please do keep this in mind. Okay, or what you can do is you can just have a screenshot of all these things right in front of you. Practice around 15 to 20 odd questions so that all these things enter into your head, and the next time you don't even have to look into these cases so that you answer the questions, right? Okay. Now, first of all, I'm going to split the numbers as numbers ending with a 0. Okay. Now, look at this. Numbers ending with a 0. Now, let me take a small number, which is 20, that ends with a 0. Now, 20 where n is greater than 1. 20 power 2. Okay, what would be the last two digits of this number? What do you think? It's going to be 400. The last two digits would be 00. Now same thing for 20 cube. 20 cube also. What would be the last two digits? Again a double zero. So you can always be very sure that any number that ends with a 0 raised to the power n, where n is greater than 1, the last two digits of this number definitely have to be a double zero. Okay, so this is one very easy case that you can just keep it in mind and leave it, right? Now, the second one, the numbers that end with a 5, the numbers that end with a 5. So numbers that end with a 5 can be split as numbers this way. Let this x be anything. It could be a single digit number, two digit number, three digit number, four digit number, whatever. But ultimately the ending is going to be 5. So raise to the power n where n is greater than 1. Okay, the first case is this number x, this value x is an even number. So if the value is x, you don't need to even look about the value of n. Okay, so if x is even, let me take a simple example. Let's take 25. Okay, 25 power 2. What's going to be the last two digits of this number? 25 power 2 is nothing but 625, right? So last two digits of this number will be 25. Now, if I want to do 25 whole cube, 25 whole cube is nothing but 15625. So again, the last two digits of this number would be 25. So if x is even, the last two digits of the number anyway would be 25 itself. Now, the second case, if this value x is going to be an odd number, then again you will have two cases. If x is odd, then you have to check whether n is even or n is odd. Now, let's take the first case that n is going to be an even number. Okay, so if x is odd, so I can take x is equal to 1. Let me take 15 here. Okay, so 15 square, n has to be even. So 15 square, what will be the last digits of 15 square? Again, it's going to be 225. Last two digits is 25. Okay, let's also take 15 to the power 4 here now. Okay, remember n has to be only even, my dear. That's why I'm skipping off a 3 there. So this would be nothing but 50625. So again, the last two digits of this number is nothing but 25. So if x is odd and n is even also, the last two digits of the number by default would be 25 itself. Right? Now, coming over with the next case when x is odd but n is also odd. Here we saw n is even. Here you have to see n is going to be an odd number. Okay. So let's take again 15 itself. 15 power odd. So 15 power 3 we'll check. What's going to be the last two digits of this number? 15 cube is nothing but 3375. So the last two digits of this number is 75. Okay. Now let's also take 15 to the power 5. And let's see what's going to be the last two digits of this number. This is going to be 759375. So the last two digits again is going to be 75 here. So if x is odd and n is also odd, the last two digits of this number is always going to be by default 75. So remember only two things we have done so far. Any number that ends with a 0, the last two digits of that number raised to the power anything greater than 1 will always be a double zero. This is very easy to remember. And then the second thing, any number ending with a 5. Any number ending with a 5. Okay, first check. If x is an even number, by default the last two digits will be 25. But if x is an odd number, you need to check if n is even or not. If n is even, again 25 would be the last two digits. But if n is odd, then the last two digits would be 75. So when a number ends with a 5, there are only two cases. Either it can be 25 or it can be 75. Okay, and it will be 75 only if x is odd and n is also odd. So you can remember only that case. Otherwise, it's always going to be a 25. Right? So we can always keep these two things in your mind. Okay, I hope these two have entered your head. Let's go to the next case now. For the next case here, the numbers in the format 2 to the power n. Okay, a few points to remember here. Remember that 2 to the power 10 is nothing but 1024. So any number in the format 2 to the power 10 would definitely end with a 24. Okay, so now you should be very clear with the cyclicity of 24. If you take 24 to the power 2, 24 power 1 is 24. If I take now 24 to the power 2, this is nothing but 576. So the last two digits would be 76 here. Now if I want to take 24 to the power 3, Okay, this would be 13824. So last two digits again would be 24. If I now take 24 to the power 4 here, then it would be 331776. So the last two digits would be 76. So I can always say 24 to the power odd always ends with a 24, and 24 power even always ends with a 76. Okay. Now, look at the powers of 76. So, we knew that 2 power 10 always ended with a 24. So, we looked at the cyclicity of 24. 24 power odd was also always 24 and 24 power even was always 76. Now, a new number 76 has come. So, we need to look into the cyclicity of 76. Now, if you take 76, 76 power 1 is 76. Now, 76 whole square is also going to be 5776. So, last two digits would anyway 76 power n would always be 76 itself. Okay, and another one major tip that you can remember when you're doing the problems is if you have anything like 76 into 2 square. Okay, 76 into 2 square. What is 2 square? And remember that 2 power n where n is greater than 1. So that's why I'm not taken 2 power 1. Okay, so 2 square is going to be 4 into 76. The last two digits of this number would be the same as 2 square, which is nothing but 404. If I take 76 into 2 cube, the last two digits of this number would be the same as 2 cube, which is nothing but 08. So 76 into 2 power 4, the last two digits will be the same as 2 power 4, which is 16. That's it. Okay, so if you remember this, any number in the format 2 to the power n can be solved. Now let me take a small example. If I have a number which is in the format 2 to the power 473. Okay, 473, and I'll not take this. I'll do this kind of a problem later. Okay, now a number which is very, very close to a multiple of 10. Okay, so I can take it as 423. Okay, so I keep it as 2 to the power 423. I know that 2 to the power 10, the last two digits is going to be 24. Okay, so I can raise it at 2 to the power 10 here, raised to the power 42. This gives me 2 to the power 420. This gives me 2 to the power 420. But I'm still left out with 2 cube. Right? 420 only was it. 3 was still left out. So 2 cube here. So now I can say 2 to the power 10 always ends with a 24. 24 to the power even into 2 cube. So 24 to the power even will always end with what kind of a number? 24 to the power even always ends with a 76. So 76 into 2 cube. The last two digits of this number would be the same as 2 cubes last two digits. So 2 cubes last two digits would be nothing but here 08. That's it. So 2 to the power 423, the last two digits of this number would have been 08. Okay, hope you're clear with this. Okay, numbers in the format 2 to the power n. Now, the numbers that end with a 1. This is very, very simple. Numbers that end with a 1. Say, for example, there's a number ABC 1 whole power PQR. Okay, so if I want to figure out the unit digit of this number, I can always say that the unit digit of any number ending with 1 always ends with 1. This we have seen in the cyclicity. Cyclicity of 1 is going to be 1. So any number ending with a 1, raised to power anything, the unit digit is always going to be a 1. Now I'm just worried about this tens place. For this tens place, what will I do? I'll simply do the C into R. C into R. Now let's take an example here. Okay. Now 241 whole power 72. First of all, the unit digit of this number is definitely going to be 1. Okay, and now coming to the tens place, 4 into 2 is going to be 8. So 81 is going to be the last two digits of this number. Now let's take 361. Okay, whole power 342. Now for this particular number, the unit digit is always going to be 1, but the tens place is nothing but 6 into 2, which is going to be 12. So 2 is going to be in the units tens place here, so 21. So this way, any number that ends with a 1 can also be solved. So far we have looked at 4 things. One is any number ending with a 0 that always ends with a 00 raised to power anything greater than 1. Second thing was any number that ends with a 5. Okay. The third case was in the format any number that ends with a 2 power n. For this, we have to remember that 2 to the power 10 always ends with a 24. 24 cyclicity is 24 per odd is always 24 ending. and 24 to the power even ending is always 76, and 76 power anything always ends with a 76. So these were the three things that you have to remember them. And numbers ending with 1, the unit digit will always be a 1. The tens place will be nothing but this C into R. So 4 into 2 here, 6 into 2 here, the same thing in the units place. Right? Hope this has also gotten. Let's go to the next. Now, numbers in the format 3 to the power n or 7 to the power n or 9 to the power n. Remember that 3 to the power 4, the last digit or the unit digit of the number is going to be 1. Okay, the same thing for 7 to the power 4 as well. Okay, I can say that the unit digit is going to be 1. And for 9 power 2 also, the unit digit is going to be 1. So any number that is in the format 3 to the power n or 7 to the power n or 9 to the power n, the number can be converted into a number that ends with a 1. And after that, you know how to solve a number that ends with a 1, right? You can follow the same way. Now, this is not only for the numbers that are in the format 3 to the power n, 7 to the power n, and 9 to the power n. It is for any number which ends with a 3, 7, or 9 also. A number ending with a 3 raised to the power 4 will always end with a number 1. A number ending with 7 raised to the power 4 will always end with a 1. Correct. So you can always convert these kinds of numbers into a number ending with a 1 and then proceed with that rule just we saw before. Correct? Now, if you have any other even number which is not in the format 2 to the power n, what you can always do is, say for example, you have 6 to the power something, 6 to the power 32. You can always split this number as 2 to the power 32 into 3 to the power 32. Now what will you do? You know for this, no, 2 to the power 10. So I can write as 2 to the power 10 whole power 3, okay, into 2 square. Got it? Now, 3. I know that 3 to the power 4, the unit digit will always be 1. So I can now raise it to the power 8. So 2 power 10, unit digit will be 24, 24 per odd 24. So 24 into 2 square is going to be 04 last two digits. Okay, and here in this case, 3 to the power 4, 81 will be the last two digits to the power 8. So here this would be 24 into 08, and here any number that ends with a 1, what will you do? The unit digit is always 1. And the tens place will be 8 into 8, 64, so 4 here. So finally, this part you have to multiply, there's no other way. So 24 into 08 you will have to do. Okay, 24 into 08. How much will you get here? What will be the last two digits of this number? 92, right? 192, so 92. So after that, you'll have to multiply it into 41. So last two digits of this number is going to be nothing but 72. Okay. So you can always, whenever a number is there, you can always split it into 2 powers, 3 powers, or 2 power into 7 power and all. Okay, you can always split and do it. Okay. Now, we have looked into numbers ending with 0, numbers ending with 5, numbers ending with 1, numbers in the format 2 power n, numbers in the format 3 power n, 7 power n, and 9 power n. Also numbers ending with 3, 7, and 9. The same rule follows. Correct? We have seen all of these. So, with whatever we have done, let us now get into a few questions. Okay, now I just have 5 questions, my dear, so that whatever we have learned so far all just gets into your head. Okay, and that is the main intention behind this class. So all these cases have to be in their mind, in your mind. You when you look at a question, okay, immediately it should pop up, right? And yeah, in time to come, I'm also going to help you out with some more good tips. Okay, we'll apply that as well. So please figure this out, my dear. I'm going to give you a total of 1.5 minutes for this. Not more than that. Please give me the answer for this. Please put your answers on the chat box. Numbers from cyclicity, questions from cyclicity and last two digits can never ever be difficult. They can be framed in a difficult way. Okay, the language can be difficult, the expressions could be difficult, but if you know all those rules, okay, you can bring it down to the simplest form. So yes, let's do start the discussion here. Okay, enough of time for this. So take one expression at a time. Take one expression at a time. Okay. First of all here, I have 0 factorial. 0 factorial is always going to be 1 and 1 square is going to be 1 here. The last two digits will be 0, 1. Right. Going on with 1 factorial. Again, 1 factorial is going to be 1. 1 square, the last two digits will be 0, 1 again. Now going to 2 factorial. What is 2 factorial? Again a 2. So 2 square is going to give you a 0, 4 here. And then 3 factorial. 3 factorial is going to be 6. So 6 square, the last two digits would be 36. Now going on to 4 factorial. 4 factorial is nothing but 24. So 24 whole square. You have to check for 24 whole square. Now 24 whole square, I don't need to even check. Why? Because I know that 24 per odd is always going to be 24. 24 per even is always going to give you 76 in the last two digits. Correct? Okay. Now going over with 5. Okay, 5 factorial is 120. 5 factorial is 120. So 120 raised to the power 2. We know that any number that ends with a 0 raised to the power 2, the last two digits will always be double 0. Same thing, 6 factorial also ends. Any number beyond 5 factorial definitely ends with a 0. Correct. So since it ends with a 0, raised to the power 2 will always end with a double 0. So all the numbers ahead will end with a double 0. So I don't need to even calculate any of those. So all I need to do is 76 plus 36 plus 04 plus 01 plus 01. Figure out all these. So just do 76 plus your 36. What is the value going to be here? 112. Correct. So 112 plus 4 is going to be nothing but 116. And 116 plus 1 is going to be 116 plus 2, which is 118. So last two digits of this number will be 18. That's it. Okay. So no complexity, my dear. Okay. Even if the question is given very complex, try to bring it down. Take one at a time, one expression at a time, and then solve it. And finally, you can apply the same operator and then finish it off. Okay. So now let's go on to the next question. Please do figure out this one. Find the last two digits of 87 to the power 73. Do this. 1.5 minutes for this as well. Waiting for the answers on the chat box. and the 10 seconds, and then we start the discussion. Okay, so before getting on to this question, I would also like to discuss a little bit here. Okay, first of all, any number that is the format 50 plus or minus x, okay, whole square. The last two digits of this number would be the last two digits. I'm discussing only about the last two digits, my dear. The last two digits of this number would be the same as nothing but x square's last two digits. Okay, now let me take a small example of 47 whole square. 47 whole square is nothing but 2209. The last two digits of this number is nothing but the same as 50 minus 3 whole square. No, so 3 square is going to be 09. So the last two digits of the number was the same as that. Now this does it apply only for 50s? It also applies for multiples of 50s. Okay, typically when the last two digits become 00 when you square it. So same thing for 100 plus or minus x whole square, or 150 plus or minus x whole square, everything. The last two digits of the number would be the same as the last two digits of x square. Okay, I'm talking only about the last two digits, my dear, last two digits of this number. So here 87 to the power 73 is going to be pretty difficult. So what I can also do is I can write this number as 87 whole square. Okay, 72 is a multiple of 2, right? So 72 here, if I divide it by 2, I'll get 36 to the power 36, and then I'll be left out with the 87 here, right? Now 87 square is nothing but 100 minus 13. So 100 minus 13 would give me the same as 13 square. Last two digits would be the same as 13 square whole power. Now 36 into 87. Now 13 square, what are the last two digits of this number 13 square? 169. So 69 is going to be the last two digits of 13 square. So whole power 36 here into 87. Now again, I can say that 69 is nothing but 50 plus 19. So I can write this number as 69 whole square whole power 18 into here 87. So 69 is 50 plus 19. So this would give me the same as 19 square. The last two digits is 19 square per 18 into 87. Now 19 square, what would be the last two digits of this number? 19 square is 361. So 61 whole power 18 into 87. Now you have brought it down to a number that ends with a 1. So this makes it much more simple for you. The unit digit of this number will always be 1, and the tens place will be nothing but 6 into 8. What is 6 into 8? 48. So 81 here into 87. So the last two digits of this number would be the same as 81 into 87. So what would be the last two digits of this number? Nothing but 47. Are we getting it? Are we getting it here? Okay. So this is something that we have learned at this particular juncture. Okay. So now let's move ahead to the next question. And again, I give you around 1.5 minutes for this. Please go ahead. This should be very easy if you had known a trick, but yeah, I'll help you out with it as well. Fast, we are going to start the discussion now. Okay, so find the last two digits of the number 54 to the power 400. There are two ways of doing it. First one, we discussed that any even number that is not in the format 2 to the power something can always be split as 2 to the power something and something else, 3 to the power or 7 to the power, whatever it is. So let's have a look at this. This number can be split as 2 into 54 is nothing but 2 into how much? 27 now. So 2 to the power 400 into 27 to the power 400. Okay. Now 2 to the power 400 is very easy for me. I know 2 to the power 10. This is raised to the power 40. So 24, okay, is the last two digits of 2 to the power 10. Whole power even, the last two digits are going to be 76. Now coming over to this particular place. Okay, 27 is nothing but 3 cube whole power 400. I can write this number as 3 to the power 1200. Now I can write it as 3 to the power 4, which will give me a unit digit of 1. So 3 power 4 whole power 300. Now 76 into 3 power 4 is 81. 81 power 300. Okay, so 76 here into. Now look at this. The unit digit of any number ending with a 1 will always be 1. And the tens place of this will be nothing but 8 into 0, which is going to be 0. And 76 into 1 is 76. The last two digits of this number is going to be 76. So this is one method. But at this juncture, let me also give you another clue. Okay. Remember that if you have any even number, let me take 54 itself. 54 raised to the power 4. 54 raised to the power 4. What would be the last two digits of this number? 54, okay, or let's not do it as 54. We know that 54 square. We know that 54 square. Okay, this is nothing but 50. Okay, 50 plus 4. So the last two digits of this number would be the same as 4 square, which is going to be here 16. So this square, 16 square, would also end with nothing but a 56. So getting it here. So 54 here to the power 4. The last two digits of this number would be 56. Now let's try raising it to the power 5. Okay, now 54 to the power 4, we saw that the last two digits was 56. Okay, now this 56, let's raise to the power 5. So that ultimately it becomes 54 raised to the power 20. 54 raised to the power 20. Okay, 5 into 4, 20. So if you have a look at this, okay, you have 56, right? 56 whole power 5 here. The last two digits of this number would be nothing but 76. So if you take any even number raised to the power of multiple of 20 or a multiple of 20, you would always get 76 in the last two places. Okay, but if you take any odd number other than the numbers that end with a 1 or that end with a 5, for that we have already seen explicitly. Any other odd number, okay, if you take it, okay, let me take a small number, 13. So odd number 13 raised to the power 4. Let's see 13 to the power 4, what is going to be in the last two digits of this number. You will see that the last two numbers will be 61. Now let's try to raise it to the power 5, so that ultimately it becomes 13 to the power 4 whole power 5, which is nothing but 13 power 20. Okay, so this would be the same as the last unit digit would be 1. 6 into 5 would be nothing but 30, so 0, 1. So always 0, 1. So you can always keep this in mind that any even number raised to the power a multiple of 20, the last two digits would definitely be 76. And if it's an odd number, which not ending with 1 or not ending with 5, because for that we have separate categories. Raised to the power a multiple of 20, the last two digits would be 0, 1. Okay, so this number belongs to an even number raised to the power a multiple of 20. Even number raised to the power a multiple of 20, the unit digit, last two digits of this number would be nothing but 76. So I would have directly done a 76 here and then moved ahead. Okay, so remember these things, my dear. See how long you could have done it, and if you had remembered just to stick, how short it takes. Okay, so next time whenever you see any question that is in the nearest to the multiple of 20s, then check whether it's an even number or an odd number, and then as per that you calculate and move ahead. So yeah, now please take this question. Again 1 minute for this, because we have learned enough of tips so that now we can reduce the calculations a lot. So just 1 minute for this. Fast. This should have been done very fast. I want the answers now. Okay, time's up for this. So the last two digits of the number would depend upon the last two digits. So this number can be taken down as 43 to the power 4747. Now I can say that 4740 is a multiple of 20. So now I can split as 43 to the power 4740 into 43 to the power 7. Now I know any odd number raised to the power a multiple of 20. Odd number raised to the power a multiple of 20. The last two digits will be 01 into 43 to the power 7. Now this number is in the format 50 minus something. So 43 whole square whole cube into 43, I'll keep it. So 01 into, now 43 whole square would give me the same last two digits as 7 whole square. Why? Because 43 is 50 minus 7. So 7 square, the last two digits will be 49 raised to the power 3 into 43. Again, I can take this as 01 into 49 square into 49 into 43 here. Now 49 square, the last two digits of this number would be the same as 1 square because it is 50 minus 1. So 01 into 1 square again is 01 into 49 into 43. So the last two digits of this number would depend upon, I'm sorry, I think it's written as 49 into 49. It is 49 into 43. So the last two digits of this number would depend upon the product of 49 into 43. The last two digits would be 07 for this. So the answer for this was 07. Great. So yeah, please do this question. This will be the last question here. Please go ahead. Please try to apply whatever we have done and try to make it as short as possible. Go ahead. Maximum 1 minute for you. By now, I should have got all the answers from everyone. Okay, so enough of time for this. So the last two digits of this expression would be nothing but 32 to the power 401. The last two digits would depend on the last two digits only, na? Plus 99 to the power 732. Now, if you want, you can apply you can apply the uniform thing throughout, or you can do two different things. One is, I know even number raised to the power a multiple of 20, the last two digits will be 76. An odd number raised to the power a multiple of 20, the last two digits will be 01. Okay, so here I can write this as 32 to the power 400, which is a multiple of 20 into 32. Okay, plus here 99, this is an odd number, right? So 99, 700, instead of doing it as 720, okay, now the problem here is this will be 720 into 99 to the power 12, right? So instead of doing that, 99 is a number which is near to 100. So 100 minus 1, it can be written as, okay, so this part I can change it in that way, 100 minus 1. So this will be nothing but 99 whole square. Okay, 99 whole square would give you the same last two digits as 1 whole square. Getting it? So what I'll do is now the 732 you divide it by 2, you'll get 366 here. So this part will give you a last two digit of 76, and this is nothing but 2 to the power 5. No? So last two digits of this number would be the same as 2 to the power 5, which is going to be nothing but 32 itself. Okay, and coming over to this particular point, this particular point here, you know that the last two digits of this number will be the same as 1 square, which is 0, 1. Whole power 366. So 32 into any number, 32 plus, I'm sorry, 32 plus, right? 32 plus. Now I know that that number is 0, 1 to the power anything will always end with a 0, 1. Why? Because the unit digit will always be 1 and the tens digit will be 0 into 6, which is going to be 0. So this is going to give you the last two digits as 33. That's all with this. Understood it, my dear? So things are very, very simple. Okay. So try to take all these cases that we have given you so far. Okay. And try to solve at least 10 to 15 problems. After that, you will not require the need to look into the cases that we have done. Okay. Everything will get in the head. And after that, you can start applying the shortcuts and making your questions much more simpler. Right. So this was the last question. Okay. And the main intention behind this session was to get all those cases into your mind. Okay. And I think by the end of this session, after doing all these questions, a good number of cases have got in. So keep practicing hard. Okay. And CAT is also very near, so start practicing rigorously, put in more hours. Okay. And yeah, study well. Thank you so much, everyone.